Okay, so now we're going to pretend like we're in manufacturing. And so maybe we own a shoe factory. And it costs so much money to make shoes. Maybe it costs, you have like overhead costs, like fixed costs. Maybe it costs, I don't know, $10,000 to keep the lights on and pay rent and things like that. But then there's a cost involved in how much it costs to make each pair of shoes. So maybe it costs $20 for every pair of shoes that you make. So X is the pair of shoes, and each pair costs you $20. So this would be then the cost of making X number of shoes, okay? That's how you do cost. I don't know why I wrote it up there, but that's called a cost function. So it's based on how many pairs of shoes we're selling. And then I kind of made up these numbers. These are fixed costs, and this is cost per item. So it's how much it costs to make each item. All right. Then you have what's called revenue. A revenue function is based on how much money you bring in for each pair of shoes. So it's based on the selling price. Okay, so maybe we sell the shoes for $200. They're really good shoes. Sell them $200 a pair. So your revenue function is based on $200 for every pair of shoes that you sell. Okay? That's how much money you're bringing in. That's the revenue. Okay. So sometimes they're interested in knowing, when does it break even? When do you make enough money to cover both your fixed costs and your variable costs, your costs where, it's per item. You're going to make money on every pair of shoes because you're selling them for 200, only cost 20 to make the shoes. But remember, you've got to cover those fixed costs, and sometimes they can be hefty. So how many pairs of shoes do we have to sell to break even? What we want to know is, when does the revenue cost equal the cost function? When does the revenue function equal the cost function? That's the break-even point. Okay? All right. So hopefully my explanation made sense. If not, it's in the book too. Okay, technology is now promising to bring light, fast, and beautiful wheelchairs to millions of people with disabilities. The company is planning to manufacture these radically different wheelchairs. Fixed costs will be $500,000, and it will cost $400 to produce each wheelchair. Each wheelchair will be sold for $600. Okay, so A, write the cost function. So we're going to be producing X wheelchairs. So it's the cost function in terms of X. It's going to be those fixed costs, $500,000, plus it's $400 for each wheelchair. So 400 bucks for each wheelchair. That's going to be the cost function right there. Okay, Part B says write the revenue function, R, for the sale of X wheelchairs. So it's going to be revenue based on X, the number of wheelchairs we're selling, and we're selling them for $600 a piece. So it's 600 times that, how many we sell. Okay. Determine the break-even point and then describe what that means. So when are they equal to each other? When does C of X equal R of X? So when does 500,000 plus 400X, when does that equal 600X? I wish I would have written it the other way, but it's okay. So subtract the 400X, and I get 500,000 equals 200X. So I'm going to divide by 200. Okay, and so X equals, and then the zeros cancel that way, if you want to do that. So what do I have, like 5,000? 2,500. Okay, so what does that mean? Well, it means we need to sell 2,500 wheelchairs to break even. And that's what it means. Okay. Okay, that's how many wheelchairs we have to sell to break even. How much money do we make? So you can go to your revenue function. That'll be the easiest one to do. So R of 2,500 is going to equal 600 times 2,500. Okay, so how much money did we bring in? Let's see. 600 times 2,500, and I get 150. I think there's 5 zeros. 1, 2, 3, 4, 5. Okay, so that's the amount of money that we brought in, but it's also the amount of money that went out. But that's why we're breaking even. But the break even point is we're going to make and sell 2,500. And then the money is 1,500, 1,500,000. Trying to write it without the commas. Anyway, that would be the break-even point.